unveiling a groundbreaking discovery, researchers have stumbled upon a hidden mechanism that could revolutionize muscle injury recovery. This unexpected finding offers a glimmer of hope for those suffering from various muscle-related ailments. The intriguing world of muscle repair. At the microscopic level, the intricacies of muscle tissue repair are far from simple. The differences between a sports injury and muscle-wasting diseases like muscular dystrophy are vast. However, a recent study led by experts at Cincinnati Children has uncovered a common thread that might just be the key to enhanced healing across multiple muscle injuries. Published in Current Biology on November 21, 2025, this eye-opening research was spearheaded by Gyanesh Tripathi PhD, with Michael Jankowski PhD, as the corresponding author. The study's twist lies in the role of a particular immune cell type, macrophages, which act as microscopic garbage trucks, cleaning up harmful bacteria and dead cells. But here's where it gets controversial. Macrophages, it seems, possess a synaptic-like property that allows them to deliver ions to muscle fibers, facilitating their repair post-injury. It's an extraordinary discovery, akin to the workings of a neuron, and it happens at lightning speed. It's literally like the way a neuron works, and it's working in an extremely fast synaptic-like fashion to regulate repair, says Michael Jankowski, PhD. Researchers have long known that macrophages play a part in responding to muscle injury, releasing molecules like cytokines and chemokines to facilitate inflammation, affect pain sensation, and promote myofiber growth and regeneration. Jankowski and his team initially set out to find ways to reduce post-surgery pain, hoping to discover alternatives to existing pain medications with their potential side effects. Instead, they stumbled upon a mechanism that accelerates muscle repair, potentially leading to new medicines for muscle wasting and aiding injured individuals. And this is the part most people miss. The study also suggests that macrophages could act as delivery vehicles for cellular therapies, opening up new avenues for treating various conditions. So, what exactly are these macrophages up to? These are infiltrating macrophages, a very specific type. They're not the ones already residing in the tissue, they come in after damage occurs, explains Jankowski. In a series of experiments using mouse models of distinct injuries, the researchers tracked the interaction between macrophages and myofibers, capturing key moments in real time. By inducing activation with short bursts of a designer chemical, the team witnessed macrophages forming synaptic-like contacts with myofibers, directly delivering calcium ions to hasten the healing process. This occurs rapidly. You can activate the macrophage and make the muscle twitch almost immediately, Jankowski adds. Furthermore, the connected macrophages triggered cell regeneration in mice with disease-like muscle damage. After detecting damage, immune cells flocked to the area, inducing waves of muscle fiber activity. Treated mice showed a larger number of new muscle fibers after 10 days compared to a control group. A similar synaptic-like response worked in both scenarios, Jankowski notes. However, more research is needed to determine if human macrophages behave similarly after muscle injury and, if so, how to control this process therapeutically. The team also aims to understand an unexplained result. While infiltrating macrophages speed healing, they don't seem to reduce acute pain sensation. Gaining insight into this could explain why approximately 20% of children who undergo surgery experience long-term pain symptoms. Looking ahead, researchers plan to explore what else a macrophage might deliver to muscle cells. What do you think? Could this discovery be a game-changer for muscle injury recovery? Share your thoughts in the comments below.